Good evening. Welcome to Space Oddities. Thank you so much for being here. And welcome back, regular viewers. And if you're new here, you are very welcome as well. Don't forget that Space Oddities is not just a live show on a Monday. We have plenty of other videos that we've created on our channel. You may want to check out some of those of various subjects. And also don't forget we have a Facebook group just simply called Space Oddities, which we'd love you to join, where we keep you up to date with what we're up to, basically. So joining me is in an illustrious panel of people. Well, I think that they can be described like that. So how are we tonight, panel?
We're fine, thank you very much.
Good. So enthusiastic.
All good. All good.
We're delighted to welcome back Mary, whom we haven't seen for a while. How are you, Mary?
I'm good now, thank you.
Good, glad to have you back with us. Okay, we have a packed program tonight, so without further ado, we're going to get on with it. But just a reminder that a bit later in the program, we will be revealing the winner of our children's art competition to win a telescope. So we'll be telling you a bit later in the program who the lucky child is who's won that Skywatcher Beginner's Telescope. And it's been a wonderful experience seeing all of the art that the children have created. And it's been a very difficult competition to judge, believe me. But we do have a winner, and we'll be revealing who that is later in the program. First, we're going to start with the man with his eyes on the sky. Roger, what's up?
Ah, right. Okay. So I will give you an update of what's in the night sky this week. with some interesting facts and images from the recent DART mission that was happening last week. Okay, here we go. Right. So here we are for the week's updates for the 3rd to the 9th of October already. So during the week, we will be getting up to a full moon for next weekend. Boo, as you say. And there we go for that. But we're still graced by the planets Saturn, Jupiter, and Mars, although Uranus is up there as well as Neptune. So they're not highlighted due to the fact of their magnitude, but they are there. They haven't gone away. And as we get through the week, we get the moon grace Jupiter on the 9th of October. And then also something similar also down in the southern hemisphere. So but they've got the planet somewhat higher up in the skies than we have, so they've got better seeing conditions of those planets as to what we do. So, but for most important was the DART mission, and this is a speeded up time lapse, if you've not seen it, of the come back to the moment of impact. This is greatly speeded up, of course. This isn't Star Trek speeds.
Yeah, because as it flies past Didymos, you get some actual detail on there, and it looks like it is a rubble-strewn asteroid. But of course, as we move past it and we come into Dimorphos, we can see it is just absolutely covered in pebbles and rocks and things like that. So
and there we go.
Yeah, the images are fantastic.
Absolutely. I'm surprised that the pictures were such a short period of time that they weren't blurred by the speed of the impact.
No, that's right. Amazingly detailed. Those final images had so much detail. They were just incredible. And there's the impact with the within the, I was reading that within just a few minutes, that expanding cloud of debris was the size of the Earth. So it's quite an amazing impact. But wow. We'll delve into that about the mission itself a bit more with Lou in a moment.
Yeah, but also keeping an eye on it, as you can see from here, we've got the Hubble and the Webb looking at the same impact from their visual and infrared wavelengths of light to see the results of how much debris was spread. Quite interesting.
And the Hubble images were great. There's an animation of them as well. That's lovely.
Yes. Just shows you how much, and this is this is a animation of the debris spreading out. Very interesting. That's what I've got to show you from my aspect. Thank you very much.
Right, thank you very much, Roger. Just give me 1 second, and we're going to talk a bit more about the DART mission because it was really the first step in sort of planetary defense. That is to say, protecting the Earth against, possibly catastrophic asteroid collisions. And just give me 1 second. And
do we know if they've managed to measure whether or not there was a deflection, or?
Oh, it's too early yet. They say they'll have some idea within 4 weeks.
Oh, 4 weeks. Okay. I was just wondering about.
It's going to take a little while, because there is another mission a European mission called Hera, which will be doing a follow-up for launch in 2024. And
to be honest, I still don't know why we're doing all these missions, because we have Bruce Willis, so as long as he's around.
Bernard, let's face it, you've got a bit of a thing for Bruce Willis, haven't you? We can tell. Anyway, Lou, first of all, perhaps you might like to just give our viewers a brief recap of what the DART mission is all about.
Sure. Well, DART is actually part of an international set of missions. You mentioned the Hera mission with its 2 CubeSats as well. And it's called AIDA, the Asteroid Impact and Deflection Assessment. So the entire Earth, of course, is concerned about near-Earth asteroid impacts. Here we see an image of the DART mission and Didymos, and either so you might say Didymos A and B, you might say Didymos and Didymoon. I've heard that, and Didymos and Dimorphos. The moon itself, the asteroid Didymos, is about a little bit less than a kilometer in diameter. Its moon is maybe 160 meters or so, and they're members of a group of asteroids called the Apollo group, and this means that they are Earth crossing, so that their furthest point from the Earth is greater than 1, or from the Sun is greater than 1 AU, and their closest part is less than 1 AU. So these are potentially hazardous to the Earth, and that's why we're sending the DART mission as one of a number of possible strategies to see if we can redirect these asteroids if we find that they pose a hazard to the Earth. So DART is, in fact, the Double Asteroid Redirect Test, and that's what it stands for.
Okay, well, moving on. This is, what basically what Roger was showing us. Did we learn anything drastically about the composition of these asteroids? Any surprises, or was this pretty much expected?
I don't think there were any surprises, but surprises would be hard to find because, for example, the moon Dimorphos, we had not seen it.
No.
We saw its effects. For those of you who'd followed our exoplanet series, Dimorphos moved in front of Didymos and blocked out its light for a while. So that's how we knew it was there, and we knew its orbital period. But we don't really know the density. That will be part of the 2 CubeSats on Hera. They will probe the internal structure of these asteroids and find out what they're made of and get a better sense of their density. And we don't know much really about their formation yet. Were they unsuccessful planets, in which case they might be very dense, or were they just material that accreted and never quite made it to a planetesimal stage? We don't know. But we will learn more about the density and mass of Dimorphos, because we're hoping to get maybe a centimeter per second change out of its orbit, and we know what the mass of the spacecraft was, and we know its velocity, so we know its momentum. So we'll be able to learn a little bit from that once that data has been analyzed.
Right. So presumably, in terms of the composition, there's never going to be a sort of a one-size-fits-all solution for dealing with these asteroids because they have such varied composition. I mean, looking at this, Dimorphos just looks like a rubble pile. I think we can agree. And I think Didymos perhaps is slightly more solid. It seems to have more flat areas on it that are not strewn with boulders. So, what works for one asteroid type obviously won't work with another, I think is fair to say.
Yeah, it's similar to Bennu and I was going to say Ragu.
Ryugu.
Yeah, I was going to say Ragu. Ryugu. And also, what took my eye when I watched this live is this little blip of light right at the bottom. You could see it quite some way off. So there's obviously it's something large at the bottom there because it's catching partial light off the thing. So there must be something, a large boulder or something there.
Yeah, something.
But it did seem sick because at first I thought
just catching the sun.
Yeah, has it got its own little moon? I don't know, but yeah, but it's obviously a part of Dimorphos. So, but yeah, it's just something fascinating. Love to see it in his life.
Bruce Willis's landing craft. That's what it is.
What was the resolution on the final image? Do we know that?
No.
Say again?
The resolution on the final image.
Oh.
Just before.
I don't know.
All right.
The final image was just a stripe, wasn't it?
Yeah,
I mean
the final full image I was thinking of that one.
So there's the final complete image.
Yeah.
And as we were watching it live, we got the sort of the top of the screen, just a few lines, and then the rest of it was red, where the picture was in the middle of being transmitted when it was when it hit. That's the final image.
That looks like maybe centimeters.
All right.
Difficult to tell, isn't it?
Yeah. I just wanted to say as well that to remind our viewers, the way we managed to sort of ascertain the composition of asteroids is by determining their density, and the way we do that is by getting the mass and of course the volume of the asteroid. And as Lou was saying, we're going to be able to really refine the mass of this asteroid to such a level that we'll be able to determine its density, and after that, then we can start to really make approximations whether it's just a fluffy type of, maybe made of rocks and a little bit of ice, or just is really hard inside. So just wanted to say that.
We've seen a few rubble pile asteroids in recent years. Perhaps there are more of those than we knew about.
Yeah.
Quite a lot of asteroids display cometary activity, don't they? When they eject mass. And actually the recent virtual telescope pictures of this moon that I've seen actually show 3 tails. The rubble or the debris that got kicked off has organized itself into 3 tails, and it looks absolutely incredible.
Wow. Yeah, because sometimes the dividing line between asteroids and comets is not clear, is it?
No.
It probably began fairly clearly in the very early universe, form outside the water and CO2 frost lines, and you are a comet, form inside and you're an asteroid. But then the early solar system was so dynamic with collisions and things flying all over the place and rejoining that there could be quite a spectrum of objects from comet to asteroid. Think of it as a spectrum rather than as a either or.
Yeah, and I think I'm right in saying this was the image from the CubeSat.
That looks right. Yeah.
Immediately after the impact. So it was quite a bang, and we're not going to know exactly whether the mission succeeded to change the orbit of Dimorphos around Didymos for quite a while, and scientists are going to have some idea, they say, in about 4 weeks when they've done the observations with lots of telescopes. But we will see whether we've managed to successfully defend Earth from an asteroid that wasn't going to hit us. But
of course, it wasn't going to hit us, but now that we've whacked it and moved its orbit, perhaps,
let's hope we've not whacked it too much.
We may need Bruce Willis.
Yeah, we may have asteroid billiards, and we'll begin a very late bombardment, heavy bombardment.
Here are 2 images from the James Webb's NIRCam camera, pre-impact and then post-impact. You can see the difference there, and again, quite a smack that the dart gave that asteroid. And here's another one, and whether you can see this properly. Webb was tracking the telescope, but it had a problem locking onto its guide stars, which was not surprising because DART was traveling at about 4 times the speed than they expected Webb will be able to track. And it managed it. You can see it's left a trail. So it did actually manage to track DART as it smacked into Dimorphos, which is an amazing image. And then we've got these as well. I'm not sure. I think, did these come from, these are from?
That's from the bot,
the CubeSat.
the CubeSat, sorry.
The
Yeah,
Chia,
they must be from the
Chia
CubeSat.
CubeSat.
Yeah, definitely. That's from
they
the
are.
Chia.
So more CubeSat images of the impact.
And these ones are really interesting because, you know, they really sort of show the explosion as filaments, and I'm not quite entirely sure why that is. Maybe Lou, you can let it inform us.
No idea. I mean, I suppose if you could inspect this, you might make some guesses about the density of the material that was impacted. Otherwise, I really can't tell.
No, it's interesting though, isn't it? The shape of that explosion. You'd sort of expect it to be fairly uniform, wouldn't you? Spherical.
Now on the moon, right? We have impact craters on the moon that have ejecta, kind of filaments of ejecta, right?
True.
So
because
perhaps
this
isn't so different.
Well, what we also got to remember is this isn't a thermal explosion. This is just two objects colliding with each other. Yeah. So this is all kinetic. There's no thermal explosion or anything here at all. It's just absolutely fantastic. I mean, you look at these structures, and of course, you probably find that the form is made up because of its construction. What its core could be. It could have a hard core, which is uneven. It's not round, and so it would cause different things to fly off in different directions. So yeah, it's something that until, is it Hera, you say, gets up there and has another look, then we'll be able to.
It arrives in 2026.
Yeah, to see what actually damage that actually caused.
Okay. So there we are. So that's DART. If you stayed up to watch that, it was, speaking personally, absolutely thrilling. I think everybody here who watched it would agree. It was you know, seeing the two asteroids as dots, or as one dot initially on the screen, and then getting closer and closer and closer and resolving into the two, and then the final approach. As Dimorphos slipped out of the picture, you've got a real sense of scale there. It was quite amazing, quite amazing. Okay, so that's DART. Just before we talk with Bernard about Europa, what I'd like to do, Michael, can I come over to you next, please?
Yep, just bear with me.
Michael's going to tell us some something about the upcoming crewed mission to the ISS.
Whoops, at the right place. Okay, just bear with me a second.
Don't forget, viewers, that coming up in just a little while, we're going to be announcing the results of the Children's Art Competition. A lucky child has won a telescope, and children who entered, if you're watching, we're going to find out soon which one of you has won.
Excuse me, I'm just having a bit problem. I'll have to do my
Bernard, there is actually a rival to Bruce Willis. Astronomy said, failing Bruce Willis isn't available, there's always Ben Affleck.
Oh,
there you go.
Well, look, and Tom Cruise, let's not forget.
He's too small to do anything.
I'd like to see him slammed into an asteroid.
I'm just going to stop my share because it doesn't seem to be working as I wanted it to. So I will talk about the SpaceX Dragon Crew 5 mission, which is going to start this week. This will be the 5th crew launched by SpaceX to the space station, and will launch astronauts Nicole Mann and Josh Cassidy of NASA, astronaut Koichi Wakata of JAXA, the Japan Aerospace Exploration Agency, and cosmonaut Anna Kikina of Roscosmos from Launch Complex 39A at Kennedy Space Center. The Dragon spacecraft in question this time is the Endurance, which last flew on Crew 3 last year, and launch is targeted for this Wednesday at 1700 hours UK time. Man, Cassida and Kikina are all rookies, whilst Wakatar will be making his 5th flight into space. With the Crew 5's launch, Dragon will be the 3rd different type of spacecraft that Wakatar has flown into space on, having flown on the shuttle and Soyuz in the past. Okay, so if anyone wants to follow that they can do on NASA TV and find that at nasa.gov. The crew's arrival at the station will bring the total crew complement to 11. In the meantime, Station Commander Samantha Cristoforetti of ESA leads the station as commander at the moment, and until she and fellow crewmates Carol Lindgren, Bob Hines and Jessica Watkins return to Earth on board Dragon Freedom in about 2 weeks' time. They've been on the station since the 27th of April. Then the 7-member and that will happen in a couple of weeks' time. So there'll be a total of 11 people on the space station for a couple of weeks until that crew returns to Earth. As I say, this week is starting tomorrow. It's World Space Week, and on the 6th of October, I'd like to let you know that the Go Space Watch has a talk from Astroscale on satellite removal plans for the low Earth orbit satellites that are defunct and causing problems in low Earth orbit in the future. Hopefully going to return them to Earth or get them to burn up in the atmosphere. So that's on the 6th of October.
Great. Thank you very much.
Wasn't there something about a European being the first commander?
Yeah, Samantha Cristoforetti is the first European woman to command the ISS. She took over on the 28th of September, and she's there until the new crew arrive this week, and then they take over. Then Samantha and her 2 crewmates return to Earth in a couple of weeks' time.
Fantastic. Okay, so moving on. We're now going to talk about the other big space event last week. It was quite a busy week in space last week. We had Juno's flyby of Jupiter's moon Europa. And I'm just going to put this up. And I hope you can see this. So Bernard, tell us about just basically about the Juno mission and then the flyby.
Yeah, totally. I mean, as you said, there's so many things happening in space at the moment. It's just so exciting at the moment. So Juno is, of course, this relatively small spacecraft, actually orbiting Jupiter. And it's mainly a fields mission, trying to really characterize the magnetic field of Jupiter and some other insights, and it was certainly not designed to be a mission that was going to return optical or images during its orbit around Jupiter. However, despite the fact that there was no budget to put a camera on Juno, the team at the time decided that they were going to put one nevertheless. So they managed, because they had no budget, they managed to secure themselves a leftover camera from the Mars descent stage, and it's really it's a wide angle camera, 11mm lens that they've attached to Juno and re-engineered it slightly in order to be able to capture images. And as we all know, it's been capturing amazing images of Juno throughout the years, mainly through citizen scientists. So images are being uploaded on the website, and then anyone can freely download it and then start to process it. So it's just been a phenomenal success on so many levels. And oh my gosh, we haven't seen any images or close-up images of Europa, this amazing moon of our solar system, for over 22 years. The last mission that managed to do such a close flyby of Europa was Ganymede, sorry, not Ganymede. Sorry, what did I say? Is Galileo, and that's why my brain was like, well, hold on a second. Yeah, so it was Galileo, the US, the NASA, the big flagship NASA spacecraft that orbited Jupiter for many years. so here we are. After 22 years, we have a flyby that is under 500 kilometers, and basically the distance that Juno managed to fly to the surface of Europa was 352 kilometers. That's 219 miles, and the closest that Galileo spacecraft managed to fly from the surface was 351 kilometers, 218 miles. So it's just it's almost the same distance as the closest flyby ever, and so Juno managed to capture with this.
Let's have a look at the image.
Yeah, totally. With this, we have images like this because obviously it's a wide frame lens, and so this is what wide frame lenses are going to do. Even though you're actually quite close to the surface, it's still going to show you the moon in full, and these images are just so beautiful, and we can really see once again the terrain and how all the ice crust is being cracked because of the shifting of all these different icy surfaces, and so it's I think they're absolutely stunning images.
Yeah, definitely. We've also got this one, which I think is an unprocessed image, judging by the color cast to it.
Yeah. So once again, we have all these. You can have access to all these raw data images from Juno Cam, and then afterwards, feel free to process them the best way you want in order to be able to really bring out the surface features of the of the moon. There's one thing I wanted to show, and I don't know, Andy, did you manage to get that image where we see the chaos terrain? Oh, well, there's that image. That's such a beautiful image. I mean, you can see we're really trying to zoom in on the surface, and again, you see all these different cracks, of the surface. And
the colors are amazing as well, aren't they?
Totally. And we're still not quite sure, right, Lou? And correct me if I'm wrong, but we're still not quite sure as to what's what the brown and reddish colored material is on those cracks, on those fissures.
Right. Well, these fissures are likely weak points in the icy crust of Europa. And there may be subsurface material, subsurface eruption of material. And so it's possible that we could be seeing a compositional difference between the surface and the subsurface here.
Right. So could these be tholins like the reddish deposits on Pluto and Charon?
Well, you'd have to make them. I'm not sure how you would make them on a moon like Europa, which has essentially no atmosphere. But again, the composition of the below the crust is unknown, except that there's fairly strong evidence that there's a large saline ocean, water ocean.
I think I'm right in saying that estimates vary for how thick that icy crust is, but it could be up to 20 miles thick. And much thinner. We just don't know at the moment, do we? And we won't know until.
I mean, because you can also tell from the original images that it's a constantly renewing surface, because there were very few meteorite impacts on there. So it's constantly renewing. All these cracks are forming rafts. All this ice is forming rafts, which is floating around. And it looks like these brown marks are wellings up from what is, as Lou said, what is ever underneath. So they could be coming from an ocean floor, or they could be just on the bottom of the actual ice sheet itself, and it's just been pushed up.
And there are also images where you've got two sections of crust that have moved against each other in a sort of a shear motion.
Yeah.
Because you see these long sinuous features, these like the rills on the moon, if you like, and there's a point where they don't meet up anymore. So like that, they move. The crust is, and that's why we think, one of the reasons we think that all of this ice floats on an ocean, because it's what we see in the Antarctic and the Arctic with ice as well. So there were. Bernard, this is the image I think you wanted to talk about.
Yes. So you can see here near the terminator at the bottom left, you can see that Juno Cam has managed to capture a chaos terrain. So it's sort of this this sort of elliptic area at the bottom left next to the dark side, where it's you can see it's all like sort of cracked. And these chaos terrains are really intriguing. We're not entirely sure how they originate from, well, what is their origin, but some of the theories do speculate that most likely underneath or within the thick ice crust, there's probably some subsurface lakes, some areas that have melted, and has just brought some weakness on the structure of the ice shelf on top, and hence why you have this chaos terrains. And we've seen them before in the Galileo images, but it's just really nice to see them here once more. And yeah,
do we have anything comparable on the Earth?
Yes, there are chaos terrains on Earth as well,
right.
Definitely. Lou, maybe you might want to chip in on that as well.
I think the physics is very similar, but of course you're operating here with no erosion, no surface erosion, or very little, at least from atmosphere or flowing water. And so the dynamics of the formation of these structures might be very, very different than on Earth. It's hard to say.
And just for the benefit of our viewers, what sort of temperature would that surface be at? Cold, obviously.
I can't remember on the top of my head, but yes, minus 100.
160 maybe.
Yeah, just incredibly cold.
It's a very cold surface. And
as I said earlier on, Roger took a photograph last night showing the X and Y on the terminator of the moon, but that was just one X and one Y. Look at all these X's and Y's on here, let's say.
That's
true. Try and catch these, Rog.
Yeah, and then
about minus 160 centigrade.
Yeah, I thought it was about minus 160. Yeah.
Look at that!
Wow.
This is amazing. This is the best image, I think.
Yeah, totally. And you know, and this is a precursor to the Europa Clipper and the European JUICE missions that will arrive in unfortunately in 8 to 9 years. You know, this is just going to be jaw-dropping once we're going to see these images in high resolution. But this is amazing already. My gosh.
It's such an improvement on what we saw from Voyager and even from Galileo. I mean, you know, the technology's moved on so far that we get these gorgeous images.
Yeah.
So there we are.
I've put the link to where people can download the raw data from JunoCam in the chat on YouTube. So for anyone that's listening and doesn't have the chat open, go and have a look there.
Oh, thanks, Mary. That's great. Okay. Bernard, you wanted to talk about Enceladus and Schnopf. Tell us about this.
So Schnopf is with an S.
It should be with a C.
C.
Oh,
that's
sorry.
Fine. That's fine. So basically, Enceladus is this other ocean world's moon, but that's the moon of Saturn. It's a really small moon, and we have lots of evidence that there's subsurface ocean underneath the icy shell. And thankfully, because a lot of this ocean is actually venting out into space from the South Pole, we managed to get Cassini, another flagship mission, a spacecraft, to go and actually whisk through these plumes, and it's managed to actually be able to identify a lot of the elements within these plumes, which are basically frozen droplets of seawater. And these elements that we managed to detect and that we believe is from the subsurface ocean, we managed to detect 5 of the 6 elements that we always consider that life needs in order to exist. And these 6 elements we call them through an acronym that's called SHNOPS, so it's CHNOPS, and that's for carbon, hydrogen, nitrogen, oxygen, phosphor, and sulfur. And with Enceladus, we were missing the phosphor. We just couldn't find phosphor, or phosphor was not measured within the samples that we were getting from Cassini and other types of ways of measuring these things. And there was models that were written that were actually indicating that yes, phosphorus was probably not going to exist in Enceladus for various dynamical reasons. However, a new, and again, you know, these are just models, but a new model has just been published by the Chinese research, and I need to check again. Unfortunately, I can't remember the name of the fellow, but basically, it's stating that. Given the new models that are based within the interior of the moon, it does seem like phosphorus would actually be able to sustain itself in Enceladus, and henceforth, you know, it raises again the prospect of potentially finding you know, alien life, or at least it raises the habitability of this world, because now, if this model is correct, then we would have the 6 elements upon which life depends. So, right. You know, again, you know, these are all speculative things, but this is the type of things that make, you know, that make science move forward. So it's really exciting. And I just wanted to clarify. So the study is led by Jihua Huan, who's from the University of Science and Technology of China. And this is also an interesting point, because China, of course, as we all know, is becoming more and more involved into space science and planetary science in particular. And so I think we're going to just see more and more of, you know, of Chinese scientists, you know, adding their expertise and their level into this. You know, for a long time, it's just been, you know, Americans, and now it just seems like more and more China is starting to influence, or Chinese scientists are starting to influence this research. So that's really exciting as well. It's very interesting. So yeah. There we go.
Yeah, because we can see on here, we can see some of the features that we saw on Europa and all that. But these blue stripes, I think they call them tiger stripes, don't they? If I remember rightly.
Yeah,
yes,
right.
Yes. There are 4 tiger stripes, and and basically what happens is that they're actually I mean, if you look at an image, you'll see they're actually glowing, because a lot of the heat from the inside of the ocean is actually going through these stripes.
Yeah, I have seen them in infrared. Yeah, so
yeah. Lou, do you want to add anything to this?
Oh, no, that's very complete. I think the surface, you were asking about organics on Europa, and we do sense some organics on the surface of Enceladus, as well as CO2 that's been identified, and crystalline water. So that likely you're seeing, again, with these tiger stripes, a difference between the subsurface and the surface. So that leads us to wonder more and to explore more the subsurface world of Enceladus, likely, as you mentioned, Bernard, a deeper subsurface ocean, I think, than Europa.
Okay, right. Well, that absolutely fascinating. Thanks for
lovely
that, guys.
Lovely image.
Oh, excuse me. Rachel, do we have anything in the viewers gallery this week?
We certainly do.
Right. Yeah, we have viewers gallery. As always, we're very grateful to our viewers for sending in their astronomical images. Keep them coming, because we do absolutely adore looking at them and seeing what you're up to. And the standard is always very high. So what have we got?
Okay, we have, let me just swap it around. Oh, okay, we have our very own Roger to kick off with 2 images. So I don't know if Roger actually just wants to say his comments on it, on the Triangulum Galaxy, if he wants to.
Well, it's something that I took last night. I had a bit of a session last night. So 2 of the images were you'll see, I guess, and also the X and Y's that the V and the X that I took of the moon, which I haven't posted.
That's lovely.
This is the first time I've done this properly. I've just recently bought myself a new camera, and it's a square format, and this is the whole of the frame. So I just about got it in with the telescope last night.
That's lovely.
That's beautiful.
And this is only 90 minutes of data, no filtration, no special filters, no optolong, just a UV-IR cut filter. And I was amazed at how much I managed to get from it. So
Yeah,
if that's only 90 minutes, goodness knows what it'll be like if I do a dozen hours or more or so on this. So
there seems to be
really
lots of
pleased.
star. Yeah, there seems to be lots of star formation
Star formation going on there, yeah.
Yeah.
Absolutely. And
I'll be catching Rachael up at this rate. But now she's gone mono.
Always trying to get the next level, Roger.
Absolutely.
Then we got Roger's Perseus double cluster as well, which I guess is the same kit. Is it, Roger? It's all the same?
All the same kit, but this is only 15 minutes of exposure just to see how quickly I can get on to the next target. It was a bit of a tight fit here, so I've sort of missed half of the left-hand cluster out, but you get the general idea.
It's very nice.
Very nice.
I'm quite impressed on how this new camera is doing.
I quite like the square format, I must be honest.
Yeah, this is the double cluster is an object that can be seen, possibly if you've got good eyesight with the naked eye, but just a small pair of binoculars and you'll pick it up. It's just below Cassiopeia in the sky, so it's quite easy to pick out. Once you've seen it, you know it's there.
Yeah.
Then we've got the Cave Nebula from Lee, which I believe is in Cepheus. I want to say it's in Cepheus. And I always love Lee's comments. And this one is, it's a cave. What's in this cave? Who lives in here? My money's on Captain Caveman tinkering with the Boulder-mobile owned by his cousins Rock Slag and Gravel Slag from Wacky Races. Here's Lee's Cave Nebula.
Oh, that's lovely.
Lee, you've done it again.
Very nice.
That's fantastic. Look at the colours. Unbelievable.
Yeah, I think we all need to move to Cornwall by the looks of it.
Wonderful.
And
thanks for that, Lee. That's wonderful.
To finish, another one by Andy, another regular image sender of the Bubble Nebula. And Andy, again, he's given us a lot of information, so I won't read it out to you. But this was all taken and imaged in one session. I think by the looks of it, is it last night, the early hours of this morning?
Oh, wow.
I don't think I've ever seen a bubble this close in before. You normally get the wide field or the bubble in the lobster claw.
Yeah.
But you feel like you could just pop it.
Don't try that at home. That's amazing. That really does stand out, doesn't it?
It really
does.
Does.
Yeah, it really does. I just love the colours. So
Andy, that's fantastic.
And really nice tracking too. Look at this pinpoint star images.
Yeah,
and
it's perfect tracking, isn't it?
Yeah.
Very well done.
Almost JWST like.
And that's this week. That's the gallery.
For half the price.
Thank you very much.
Oh, just a bit.
Okay, right. Just give me 1 second. We're now coming to the part of tonight's show that we hope you've all been waiting for, which is, of course, the result of our first ever competition here on Space Oddities. So we'd like to thank everybody who entered the competition, thank all the children who took part and gave us so much pleasure looking at their wonderful images. And as I said earlier, it was not an easy competition to judge because the standard was so high, but we did have a winner that emerged. So what I'm going to do now is I'm going to take you through the entries and then we'll find out who the winner is. So just 1 second and let's have a look. Okay, so first of all, as you can see, the prize for this competition was this lovely Skywatcher telescope, suitable for beginners, a reflecting telescope. And that was the prize kindly donated to us by Rother Valley Optics. And we're very grateful to Rother Valley Optics
Thank you very much.
for providing that prize. This first one, this was a lovely image of Mars by Oliver, aged 10. And I love this one. I love the colours and the Mars rover as well, which was absolutely lovely. So well done, Oliver. That was a fantastic image. Really good.
Do we know which rover it is? Did he specify?
No, but
Okay.
it's a sort of, I think it's a generic Mars rover. It's practical. I mean, it's got the wheels and the suspension and everything, and a camera. So it's
Looking good.
It's a practical rover. Well done, Oliver. Well done.
Looks a bit like the Rosalind Franklin rover.
That's not there yet.
I
know. No, indeed. So thank you for that, Oliver. Much appreciated. And then we had this gorgeous image of Saturn by Heidi, age 9. And I think we all loved this one, didn't we?
Yeah.
Well, we love them all, but this one of Saturn we liked a lot because the colors and the way that Heidi drew this. So well done, Heidi. That was a fantastic image.
Saturn's rings are hard. You did really well there.
Yeah, absolutely. And then we have Emily, aged only 6. Well done, Emily. Thank you so much for your lovely image of the Earth. And I see you've put your daddy and mum and the baby there. So thank you so much. If you have a baby brother and or a baby sister, that is absolutely fantastic.
Is that the NASA spelling of Earth?
Yeah, absolutely.
It's a lovely picture, lovely.
Yeah, absolutely. So well done, Emily. Thank you so much for that. Then we have Uranus from Joshua, and a lovely image of Uranus, of course, showing the ring, and a lovely background, and well done, Joshua. Lovely image.
Yeah, lovely.
And there is Joshua with his picture, and your mummy or your daddy said Joshua is very eloquent on the features of Uranus and has detailed the spot and the ring. Yes, and you can see the dark spot that was discovered by Voyager that actually didn't last that long, because a couple of months later it had disappeared altogether. It was a storm, of course, in the atmosphere of Neptune, because Neptune has a very, very dynamic atmosphere that's changing all the time, and that is a lovely image. So thank you very much, Joshua. Kynan sent us this image of Mars, which is great, because I think he's captured some really good landscape features of Mars there, and a space probe as well. So that's a lovely image. So thank you so much for that, Kynan. And then Kynan chose Mars as his favorite planet because one day he hopes that humans will be able to go there and build science labs to do lots of experiments to see if humans could one day live there. Absolutely. And in your lifetime, Kynan, I'm pretty certain you're going to see that happening, and before you're much older, hopefully. But yes, we all hope to see humans there, and you will see it in your lifetime of that, I'm quite sure, and that will be really exciting, won't it? So thank you very much, Kynan, for your lovely image of Mars. Then we have the Earth again, a different view of the Earth from Sean, age 5. Lovely Earth here, with the continents and the ocean, and it's a beautiful image of Earth
and other planets.
Yeah, absolutely, and the planets behind it.
Went all right, yeah.
So thank you so much for that, Sean. Thank you so much for sending that in. That's a beautiful image of the Earth. And then we have this image of Jupiter by Joy, and she said, "I love Jupiter because it has an eye like I have." And she has captured that eye really well here, the great red spot, of course. And she did this in acrylics. And I think it's an absolutely beautiful image of Jupiter. And I gather that's meant to be the Milky Way in the background at top right as well. So she's got Jupiter and the Milky Way behind it. So so a really lovely image. So thank you, Joy, for that. Thank you very much indeed. Saturn, another Saturn from Flower, age 7. And Saturn, you've done a great job here. You really have. You've captured Saturn perfectly. Yeah. Do we all like that one? We all like that one.
Very nice. Yeah, well done, Flower.
Well done, Flower. Well done. That's a great effort. Carry on drawing pictures like that, because they're absolutely lovely. Thank you so much for that. And then lastly, I believe, Jupiter, another Jupiter from Tom, age 9. Tom says Jupiter is his favorite planet because it has an interesting past. That's absolutely true. And it's a past that the Juno space probe has been trying to unravel since its arrival there in 2016, because we don't actually know an awful lot about the distant past of Jupiter, but we're finding out more all the time, largely thanks to Juno. He finds the great red spot fascinating and is amazed at how big it is. Well, it is big, isn't it, Tom? Because the great red spot is, just a little bit bigger than 3 times the diameter of the Earth. So it is a massive storm. And we know that that storm has been raging for at least 400 years, because I believe it was Galileo who first spotted it. And you know, we don't know exactly how a storm can rage for that long. Imagine having a thunderstorm on Earth that lasted for 400 years, or a hurricane. That would be quite something. So lovely image. Thank you so much, Tom. That's a beautiful image of Jupiter. And now we come to the crucial moment, of course. The panel have cogitated and what was it Lloyd Grossman used to say? Anyway, we've come to a decision, and we have all voted, and quite a few people involved in the judging, and we have come to a winner. So the lucky child who will be winning a telescope is Joy with her image of Jupiter. So well done, Joy, if you're watching. Round of applause for Joy, because that is an absolutely smashing image. We all love that one. And that was the winner when we tallied up the number of votes for each one. So thank you very much. It's wonderful. We will be getting the prize off to you, or Rother Valley Optics will be getting the prize off to you shortly.
It's being sent out tomorrow.
It's being sent out tomorrow.
Yeah,
so not long until you have it. No. And well done from everybody at Space Oddities. We did say that every child will receive a prize of some sort, and we're true to our word. Every child who entered their drawing in the competition will be receiving a consolation prize, and Daz has got that organized. And when are you sending those out, Daz?
Probably in the next couple of days.
In the next couple of days, we'll send the prizes out to you. Everybody gets something out of this competition. So if you didn't win the telescope, don't feel too bad. You will get a small prize as a present from us just for taking part.
We'd like and always enter the future competitions, because one day...
Absolutely. We will be having a competition every month here on Space Oddities with a prize. October's competition we will be announcing hopefully next week. At the moment, we're not quite sure what the prize will be, which is why we're leaving it till next week to announce. But we will be having another competition with a prize in October. So stay tuned to Space Oddities next week. And if we don't announce it next week, we will definitely do so the week after. And stay tuned, and you'll find out what you can win in our October competition. And once again, thanks to Rother Valley Optics for providing the prize, and it's much appreciated. So there we are. So that is the competition for September. Well done to everybody who entered. A special congratulations to Joy, of course, and thank you. Thanks.
Yeah, well done, everybody. Well done.
Yeah, a round of applause for everybody, because I think they all did very well. It was so difficult to choose a winner out of all those lovely pictures. Okay, well. How are we doing for time? Just to time, I just want to mention a couple of very, very brief items just to finish off with. And just let me set this up. And been a couple of things in the news this week. The first is that there is a plan to lengthen the life of the Hubble Space Telescope, and I hope you can see this. I just seem to have lost my. Okay, give me 1 second. I've just had a momentary glitch, which I will try and get over right now.
Yeah, people in the chat are all mentioning how they enjoyed the images from the children, and they were all
good. I'm so glad, because you know that makes it all worthwhile.
It's like we said, we wish everybody could have won, but the choice was so hard. Yeah.
Okay. I've just got a technical problem with this slideshow. 1 second. Oh, okay. Right. Can everybody see the Hubble Space Telescope?
No, we can see the competition.
Let me just try sharing that again then. Right. Okay, I think it should be there now.
Yeah, that's it. Yeah.
Right. So what's this all about? The Hubble Space Telescope is reaching the end of its life. As we know, over the past couple of decades, it's given us amazing views of the universe that many people just didn't expect. We're all familiar with the glorious images from Hubble, but it is coming to the end of its life. It's not going to last forever. One of the reasons it's coming towards the end of its life is that it's losing its orbit. It's sinking lower into the Earth's atmosphere. And now there is a plan to actually reboost it further up in its orbit so that it will last for longer and won't crash into the atmosphere and burn up. And the plan is for SpaceX with their Dragon capsule to mount a mission to actually push the Hubble Space Telescope with the aid of its engines, of course, to a higher orbit so that we get a few years more life out of the Hubble Space Telescope. Michael, do you know any more detail on this?
I don't know very much. I'm just wondering, a couple of years ago, they put an attachment on Hubble, didn't they, with one of the final servicing missions, is that right? Yes. And I was wondering whether they're going to modify the nose of the Dragon to have an attachment to match up with the attachment on Hubble, so they can use the engines of the Dragon. I don't know. I'm only just thinking, you know, one thing they could do, because they have obviously on the one Dragon they've replaced the nose cone with like a cupola window, haven't they? Right. So perhaps one of the Dragons could be modified with some kind of docking mechanism.
So this would be using its Super Draco engines, presumably.
That's right. Yeah. That's
boost the telescope into high orbit. Yeah. Well, let's hope it works. It is only at the conceptual stage at the moment. It's not even at the planning stage. It's only an idea.
This is all due to the private team looking at this.
Part of the Polaris, isn't it?
Part of the Polaris program, a possible part of the Polaris program run by Jared Isaacman, the billionaire. And if this does come off, it would be no cost to NASA or the government. It would be done as part of their fundraising for their children's cancer hospital that they're doing. But obviously, if we can extend the life of Hubble for another 10, 20 years, then that would be an amazing advantage to modern science, and it could, to complement the James Webb as well.
Absolutely, and just to remind you, Jared Isaacman is an amazing guy. He's very rich, but everything he does in space is, as you said, to raise funds for a children's cancer hospital, famous children's cancer hospital. I can't remember the name of the hospital off the top of my head.
It's St. Jude's Hospital in America.
And I think he went up as a space tourist, and I think they raised about $200 million.
Yeah, they've raised so much more than their original target was raised.
That's right. I think it was about 200 million.
Their next mission is coming up this December, Polaris Dawn, and that's going to be another private mission by Jared and his crew, and they're going to be doing the first spacewalk from the Dragon on that particular mission. So that will be the first commercial private astronaut spacewalk.
Yeah,
that's something interesting to look forward to in December.
So the next time anybody says to you, viewers, that space travel is a waste of money and doesn't benefit anybody, which we know to be false, of course, you can point to the 200 million raised for St. Jude's Children's Cancer Hospital just from one space mission. So there's ammunition for those idiots on Facebook for you. So to beat them over the head with, because God knows they need it. Lastly,
can I just ask, going back, regarding Hubble and SpaceX you can so see the headlines. There's going to be things like Elon saves Hubble and things like that, right?
Yeah. But we don't pay attention to those people. They're not even worth considering. So lastly, we have to report the sad death of SOFIA, which is the flying infrared telescope flying in a converted 747 it's an infrared telescope. It started its missions in 2007, and it's just become too expensive to maintain, I think. Lou, is that the exact reason that SOFIA's been cancelled? Is it a maintenance problem? Is it a cost problem? What's going on?
I think it comes down to budget. You know, there's a lot of benefit to having these airborne observatories, and of course, SOFIA is a successor to the Kuiper Airborne Observatory, because you have a large aperture telescope flying above essentially all the water vapor in the Earth's atmosphere, and you can bring it back down and you can fix it. I mean, it's not like a spacecraft where it's either out of reach or it costs an awful lot of money both to launch and to attempt any sort of repairs. So it seems to me that it's a very cost-effective way to view the infrared universe. But I suspect, as with so many things, it comes down to budget and priorities.
Yeah, I think I did read that some of the parts for the telescope were getting hard to maintain as well. So,
I'm a bit surprised with regards to I mean, of course, the budget is a problem, but this was in association with the German Space Agency, right?
I think
remember
private company on the East Coast actually won the contract for it. USRA, I believe, University Space Research Association. I don't know what their partnerships are.
Yeah, I think they were passionate with German companies, but also didn't it fly out of New Zealand a lot of the time as well? Because also this is the very last 747 of its type also that's flying. So there's two sad moments there. Just sorry, Joe, just I've got my hand up because I've lost it now. Astronomy Nebulae says you could always put the Hubble in Roger's back garden with his 100% clear skies, and of course Roger's all thumbs up with that. And Mary's put maybe Roger has a secret 747. So it's we never know, because it does seem to be a very strange that he gets all the nice skies. He blows everything our way. I think that's what it is.
Absolutely.
And I'd just like to mention one more piece of news, just very, very quickly. Ingenuity, the little helicopter on Mars, has completed its 33rd flight. There was an issue that they're looking into. It appeared that maybe some debris fell off of one of the legs, but they're looking into that. But it successfully made its 33rd flight. Considering it was only supposed to do 5, it's earned its
yeah, well done, Ingenuity, the little helicopter that could.
Yeah,
definitely. Well, that brings us to the end of tonight's show. Thank you so much for watching. Please hit the like and subscribe buttons. Yes, Mary.
Sorry, Rachel's put a quick question in the chat from one of the listeners.
Where are we going?
Andy Weller has asked if SOFIA is redundant now that James Webb is up and running. Is that one of the reasons?
It possibly is, but SOFIA did produce some very, very interesting and very striking science while it was running. And it probably is just down to, like Lou said, it's budgetary reasons. It would be lovely to have all these strings to your bow, but something's got to give. And as we said, James Webb's only just started, and we don't know what that's going to give us, and we know it's wonderful.
Of course, you can, unlike James Webb, you can swap out detectors on SOFIA. So the wavelength range is, I mean, it's not infinite, but it's variable. So I wouldn't say it's completely redundant with James Webb. And we have other infrared observatories that sit on the ground and do very nice work. And
yes, let's not forget that.
I mean, with SOFIA as well, I mean, it virtually takes 24 hours for a mission from beginning to end, because they have to fill the aircraft with coolant to keep the telescope cold. That has to be done. The crew and the astronomers all have to be briefed for the operations. And then, of course, it takes off. It's got to reach its destination and follow its flight path. And then it runs all through the night, and then it lands. So it's literally a 24-hour mission when you fly this. So it's probably quite an expensive business with all the time that goes into it.
And, you know, it's a shame they couldn't have kept it going, you know, alongside the James Webb. But as you know, Mary, you can never have too many telescopes. So
indeed.
Of course, there are some good reasons to have a mobile observatory like that. If you're viewing stellar transits, for example, trying to get atmospheric composition for a Titan stellar transit or something. If your ground-based telescope is not in position, that's too bad.
Yeah.
But of course, SOFIA could be. Anyhow, sorry to see it go.
Bernard, you wanted to say something?
Yeah, I just had a correction earlier on when I was talking about Europa, and we saw the chaos terrain from Juno's image, and I think you asked me, do you find these on Earth? And I said yes, but actually I had to do cross-check. I had a bit of doubt there, and no, you do not find chaos terrains on Earth. I just
really?
Put
So
this out there,
they are unique to the.
Well, apparently we can see them on some other planetary
Mars
bodies.
Has got chaos terrain,
such as Mars, yes, and Mercury as well. But there you go. I just wanted to make that.
There's
correction.
no earthly analog as such.
Stan's just asking, can we next week post Roger's X and Y photos? He'd like to see them.
Have you got your X and Y available now, Roger, that we can quickly put up?
I will have a look.
Right. In the meantime, I'd like to thank you all for watching. As I said, do like and subscribe. That really helps us to keep the channel going. Hit the notification icon. Find us on Facebook. Big thanks again to Vorther Valley Optics. And big thanks to the panel. Mary, lovely to see you again. Rachel, thank you for the gallery yet again. And Roger, thank you for well, whatever.
And thank you all the children who were in the competition. They were fantastic. Thank you.
Big thanks to Lou for his NASA expertise, of course, and Bernard.
Okay, I got it.
Okay. I was about to say thank you to Bernard for his expertise in the ocean worlds of the solar system, on which he's written a book. So I can testify that he knows what he's talking about. There we are. That's
a good one at it.
There's the V.
There's the B
and a little X there.
And a little X there. And this is only visible when exactly, Roger?
It's not visible every lunar phase, obviously, because it might be before or after it rises during our visibility, or it might be during the daytime when people aren't able to see it properly. But Mary has got it on her website when it is visible through the year. So I don't know whether it should be visible again before the end of the year, no problem, probably a couple of times, but I'm not sure the exact date.
Yeah, I published the times in UT on my website for anyone. So if it might be not visible from the UK, but it would be where you are. So I will find the link to that article.
How can people find your website, Mary? That's what we.
Well, this is actually my blog page, so I will send it to you, Andy, to stick in the description box.
Thank you very much. That's great.
I don't
that's
know
it,
the
folks,
website.
for another week. We've really enjoyed ourselves tonight, I think, and we've loved having you with us. A big thank you to everybody who entered in the competition. And of course, we will be back same time next week with more amazing stuff from space. So from everybody here at Space Oddities, say goodbye, panel.
Thank you. Bye.
Goodbye,
Hit those
panel.
likes. Hit the likes.
Bye.
Bye. See you
Good night.
next week. Have a great week. Take care.
Ta-da.
Bye-bye.